All right, so this is the second day looking at the normal curve. But as mentioned, today is related to yesterday. The only difference is yesterday we were only able to assess when it's 1 standard deviation from the mean, or 2 standard deviation, or 3 standard deviation. Now we're going to get more specific and be able to figure out, well, what if it's positive 1.43 as one of the boundaries, and it's negative 0.67, okay? So you see they're not going to be the whole numbers where it's 1 standard deviation, 2, 3. But this process would work with what we did yesterday and what we had to accomplish, because really all it's looking at is some value. If it's negative 0.73 or if it's negative 1, you could still plug that in. It's the same process, but it doesn't rely on the identities of the 68, 95, 99.7 rule. Okay, so same as last lesson, but not with the whole number values. So these are hypotheticals that we would have as boundaries, 2.3 sigma and negative 0.75 sigma. And those would just be the boundaries, right? There is one subtle difference I'll get to in a moment on using the z-score and what that gives you. But to start, in order to find the standard deviation, it is a pretty complex method. You have to use a summation, which basically is adding together more than one value. So here's x sub 1, but then there's x sub 2, there's x sub 3. In relation to the mu, you square that and then you divide by the number of entries that you have. Luckily, this lesson suggests using technology so that we focus on the other aspects, and I'm happy with that because we're going to learn summations later instead of spending a week on that. So I, in Edmodo, put a link to a calculator that helps you find the standard deviation because you're going to have a lot more work to do. I don't want you to get burnt out just trying to find that. And we haven't learned summations yet, so it's not the right time to bring it in. In average, the mean is pretty straightforward. You add together all the values. If these were test scores of all my students, there would be 170 of them, and then I would divide by 170. Okay. Pretty straightforward over here. I do have you write those down because I want to refer back to this later. But you will have to find the average in the homework and on the quiz coming up Friday. So again, the z-score gives a standard deviation above and below the mean. It may not be a whole number. So we are going to just look at, we're going to be looking at different standard deviations, and we're going to use our z-score chart to find the percentages that are related to them. Okay. If we have to find the z-score, so for instance, the z-score of 1 standard deviation, the z-score right here at 1 standard deviation is 1. But there's a difference. So I'm just going to write on the board a bit. Before we were learning from the basic identity, here's mu, and here's 1 sigma, here's negative 1 sigma. We knew that it was 1 sigma deviating, 1 standard deviation from the mean. So we knew that was 68%. When we use z-scores, this is the main difference from yesterday to today, the main key difference. I said key. All right. If we have 1 standard deviation, mu, negative 1. When we're dealing with the z-scores, this is with z-scores, then we end up finding what the percentage is below that value, the z value, all the way over. It's going to be different, right? Because what are we adding? With the z-score value, we are adding all of this, and we're getting this entire tail is being added on. So it's going to be more than 68. So the long way around this, if you have standard deviation, 1, 2, 3, use this method. But you could figure it out this way, because then you could find the z value and percentage for negative 1, right? And then just subtract out that negative 1 percentage. So if I knew that, let's hypothetically say that this is 80%, right? And this from negative 1, this is 12%, right? Then what is it going to be between 1 and negative 1? 80. This is 12. 68, right? So if I find the z-score of 1, it gives me everything left of 1, everything that's less than that. From negative 1, it's everything that's less than that. So to find this, to find what actually is between negative 1 and 1, I'd have to subtract out this value. Let's see. So that's how we would do yesterday's homework if we wanted to try it this way. But let's move forward to what we're dealing with today. Let's see. In this example, what percent is less than negative 0.53 sigma? So I look over here, 0.53, it's not even to where it's at negative 1. Here's 1 sigma. It's kind of in the middle right here. And if we find the z-score, or excuse me, if we already know the z-score is negative 0.53, but we'll find the percentage that are less than that by using the z-score table. And now I will introduce you to your new favorite best friend. I thought I was their best friend. Dang it. It's okay, you're both best friends with this table, so you can complain about how amazing it is. So again, look at the diagram up here. Here is my z value, right? And what the z table tells you is that it's everything less than that value. That's the main thing for today. If you didn't know that, you get to the homework. If you try to make it like what we did yesterday, it's not going to work out. But who thinks this table looks ridiculous and really confusing? Probably everybody till you know how to use it, right? So give me 1 minute, and I will zoom in. And then we're looking for negative. Too far. No. There it is. Okay. We were looking for negative 0.53. That's our z value is that. This is how we're going to figure this out. You go down to negative 0.5, right? In fact, this is where any opportunity to use a laser in class, I'm going to do it. All right, negative 0.5 right here, right? How am I going to get that last little 3/100ths? What do you think we're going to do? Look at the top row. You see the top row? 0.00, 0.01, 0.02, so on, all the way, right? So I go first to find my row. What am I looking at? I'm looking at negative 0.5, but then I go up to the row up here, and I need to add that 0.03 to it. I go down, and we have 0.2981. 0.2981. So we have 0.2981. How about as a percent? 29.81%. Okay. So let me just bring that back to what we were looking at. What we just figured out was from the z-score of negative 0.53, we know that this area over here, this area is 29.81% of the total. You can also verbalize it. 29.81% are less than negative 0.53 sigma. Gene, question?
Yeah, so if you were to plug that into the equation, would x sub 1 be negative 0.53?
Actually, in this case, the z-score would be over here, negative 0.53. X would be, I want to show actually how to use this equation with a different example. So hold for 1 second. Okay. Let's look at this example up here, and that's going to help us find the z-score. So let's turn that. People are going to love that. Can't even see. All right, do your best. This is the SAT math. We look here in the mean. The mean is, mu is 514. Standard deviation, 117. Stephanie's score, which I say is x sub 1 because I could be looking at hundreds of scores, and I don't want to get them mixed up. X sub 1, the next person, x sub 2, is 680. So what is Steph's z-score? So first off, for finding the z-score, we need to know x sub 1. That's the value we're looking at specifically. We need to know mu. We need to know standard deviation. Do we have all that?
Yeah.
We do. So let's go in and just put z is equal to 680 minus mu, which is 514, divided by standard deviation of 117. Okay. So sometimes you're going to be given parts of the information and not the z-score. you go ahead and you can figure out the z-score from here. Okay. If they specifically tell you, I want you to find what is less than negative 0.53 sigma, then negative 0.53 is your z-score. Okay. What we're basically trying to figure out is, what is Stephanie's z-score? And when I do part B up here, I think you'll see how it connects together. Okay. What do we get? You guys know. Tell me. What do we get? 1.41. Did you round up or down for that? You rounded for that?
No. If you rounded it 1.4.
Yeah. So the key is we're going to round to the hundredth because the chart goes to the hundredths, and you would round anyway to find the appropriate value. I'm not sure they make z-charts that go to the thousands. I'm sure calculators depend on that. But we are going to the hundredths. Our z-score is 1.42. So let's look at this a little closer and see how that fits in with this. Standard deviation is 117. So to get to one standard deviation from 514, 514 plus 117, oops, too many ones, delete, so is 631. We go to the second standard deviation plus another 117, 748. So you can see that Stephanie fits between the first and second standard deviation, probably pretty close in between. Here is the 680 score. So does that match what I found for my z-score? Is it about 1.42 sigmas over? Let's see, 68 does kind of fit right there. I know 1 was 631, 2 is 748. That actually makes a lot of sense. So what we're going to figure out now, that we figured out the z-score, we know where it fits and how it's relating here. What % of students scored less than Steph? So we're trying to find all of these students. Okay. We're going to do a few example problems, so you'll have more chances with this. Let's see. How could we figure this one out? We need to use our z-score, so I'm going to bring that screen back down. We were in the negative side yesterday. Yesterday. A second ago. This is also, this exact same one is on Edmodo. In the one post for today, everything is connected there. And now we're going to look at 1.42. So with your neighbor, go ahead and decide what value are you going to use for 1.42. Go ahead and get that value out. You guys forgot your binoculars? 1.4?
Yeah.
I'm trying to allow you to see the top row, so I guess I could zoom in a bit more. Let's see. And we could just move that down. Zoom more. A little bit easier. All right. So you go to 1.4, and then what do we need to do? We need to look at the column that's under the 2 hundredths. So what do we get? 0.9222. All right. So the z-score is really helpful because, wow, I just figured out how many values or what percentage below that z-score. Z-score is just where you are as far as your sigmas. So what did we get? 0.9222. Give me that as a percent. Okay. Let's say that there were 1,500 students. Our n value is 1,500 students altogether. How many students did she score better than? What do you think? Quite a few students, right? Gene?
I got 1,383.3.
Okay, so we don't count part of a person. A third of a person. I mean, what part would you count?
Only my head.
Just their arm that's doing the test?
Yeah.
One. So yeah, we're gonna round. We're gonna round to the nearest value, but it was 0.3, so we'll stick with that. And actually, if it's specifically about students, you would always round down because you can have a partial. Yeah. So mostly, in general, we're going to be rounding down, but it may be a value that we're trying to find and keeping that decimal. So just keep that in mind. Just logically, which makes more sense. Okay. Thumbs up, sideways, down so far. Okay, good. I like that. That's good. Okay, using the chart, no big deal. Easy now. Okay, it's your best friend now? Not BFF first yet, but friend. Oh, dang, that's quick. Done 5 days. Yep.
How would you find it without the chart?
Without the chart? Well, some aspects you would be able to find without the chart, but without the chart for this one, wow. I mean, nah, you'd have to use calculus for it. Because what you'd be doing is breaking up smaller and smaller bits, right? Smaller and smaller bits. You could break this up and make a proportion, but really, that wouldn't even be the right route. We're going to depend on the z-score until calculus. Is that all right? All right, let's see. Did we already find this? We got enough practice with that, I think. That was just use the z-score table to find the percent below a z-score of 1.43. We would just find 1.43, and that would be our go-to right there. So we've done the problem with Stephanie. I want to bring up now. I'm going to do it over here, and we're going to look at a problem that has the next level of complexity. But we're like 80% through what we have to master today. So looking at this again, let's look at 3 and 4. Too close. 3 and 4 right here. All right. Hey. A lot of people at home getting sick. Sorry for the seasickness. That's fine. Okay, let's look at 3. We're talking about a factory produces plastic cell phone cases to fit properly. Each case must have a width of 53.5 to 54.5 millimeters. Who's gotten a phone case that didn't fit before? Anybody? Yeah. And it could be the wrong model or something weird, or it could be that the factory had deviation from their mean, from what they wanted that was too great. Okay, again, SpaceX wants that standard deviation from what they want. They want it to be very small degree of error to like the 10,000th place. Like they will be very, very specific on exactly what they want. Because if it doesn't fit, it doesn't fit. So let's just go ahead and write down what we know so far. We know that it's producing cell phones. We need it between the range of 53.5 and 54.5. Let's see, we're going to make 100 cases. Quality control is going to see how many of those 100 cases, well, we're using 100 cases to see that it's normally distributed. The mean is 54.2, and I'm guessing the mean is what they want it to be exactly, right? I mean, you're not going to make what you're going for. The mean is what, if you're producing something, is what you want to produce. You're going to have deviation from that, but here's our deviation. So let's put in 1, 2, 3. 1, 2, 3. We're going to add 0.3, so it's 54.5, 54.8, 55.1. Go the other direction. -1, -2, -3. 53.9, 53.6, 53.3. Okay, those are our values. Now go ahead and bring in our boundaries that we're really interested in. 53.5 is somewhere like right here. 54.5, oh, look at that. That actually is the first standard deviation. So all we did was, I took the mean, I used standard deviation to find the other values that are at each of our main sigma points. And then I went back and saw they want to make sure each case is between these two. This is our parameter. So I just put those in there. And now we want to see what fits in between them. Okay. Now, let's see. Yeah, okay. What % of cell phone cases meets manufacturing specifications? Now, follow me with this. Let's see. If I find, using a z-value, a z-score of 1 right here, right, it's going to tell me the percentage of all values that come before it, the entire graph to the left, right? If I find the z-score using whatever my z is going to be for 53.5, it's going to tell me the percentage that is that side, right? So what I'm going to do is find the percentage value for 54.5, and I'm going to subtract out the 53.5 percentage. You see how that will give me everything shaded green in the middle? We're going to do it, but that's where we're going. That's the main thing. You got to see, you're going for the upper boundary and you're subtracting out the lower boundary because I don't really care about what's over on this side. I want to know the percentage between those two. All right. So we need to find our z-value for this first. Z-value is x1 minus mu over sigma. Do we have everything to figure out that z-value? I think so. Let's do it for this one right here. Z is equal to 53.5 minus my mu, 54.2, over sigma. We can find that right now. If Alright, let's see. Is anybody way ahead? There he is. Minus 54.5 divided. Alright. That's not right. Say again? Right. I think it's 3. One moment. Let me do it again. 53.5 minus 54.2 divided by 0.3. Negative 2.33 repeating. So I know that this z-score is negative 2.33 repeating. We always round the z-score to the 100th place. So I then bring in our favorite. How could you be put below there? Get out of there. All right, I'm going to bring in my negative side. And I'm going to look at, let's look, negative 2.3. I'm going to go over, and it's not over 3 columns to get to 0.03. Remember, the first column is 0.00. That's where there's no deviation from our first column's value. So we have it here. We go over, and we have 0.0099. So small. So this portion right here, is 0.0099, which is 0.99%. It's less than 1%, just barely. The 99%. I see 99-cent store. It doesn't work. Never mind. And then what are we going to have to find as far as this one? What number am I looking at for my z-value? 1. Why isn't it going to be 68% again? Why is it not going to be 68%? It's 1 standard deviation, right? What was the reason why it's not 1%? It's everything over. It's from 1 standard deviation here at 54.5. It's everything over to the side. Remember, 1 standard deviation from the mean is 68%, but we're talking from 1 standard deviation all the way over. Okay. So we better get to the positive side and find 1. Okay. We go to 1.0. We go to 0.0. It is 0.8413. So where z is equal to 1, it is 0.8413. What's the percentage for that?
84.
Perfect. So we know the percentage. We know the percentage for everything to the left of 1 standard deviation, which is one of our markers. We know it from the other marker that we were given. So what should we do with these two values? Subtract. Subtract. So I'm going to go here and notice that this that I just made cross-hatched, that is, it's just minus 1, that's 13, right? So 83.14%. That's our answer. That's as complicated as it gets for the entire week. Does everybody see how you have to look at the different boundaries? The hardest part of this is seeing that I know that the value for the z of 1 is going to be everything to the left. For z is negative 2.33, it's going to be everything to the left. So I need to subtract out that part. I need to subtract the 0.99% from our 84.13%. All right. Pretty good. Thumbs up, sideways, down so far. Thumbs up. Good. That's a lot of thumbs up. What time do we have? Just about done. Okay. Any questions on this? Clarifiers? Yes, Lucy.
Where did you get like 0.99?
Where did I get that?
Yeah.
So we found out, knowing that 53.5 was our x value for that. That's our value we're interested in. We know the mu, which was 54.2. So I put that in there, subtracting. I know my standard deviation. So from that information, we figured out z is negative 2.33. And what that gave us, if we look back at the chart, negative 2.33, right? Negative 2.3, you go over further to get to 0.3, and that's where I got the 0.0099. Make that into percent, what happens? 0.99%. Good? You sure? Okay. Anyone else? No? Okay. I think that might be where we end it then. You guys haven't some half of you know. All right. We're gonna do subscribe on 3. Ready? 1, 2, 3.
Subscribe.
All right. First time not bad. First time not bad.